Hello, my name is Vishruth Hanumaighari, and my partner is Nikhil Chitluru. So to begin with the structure of the neuronal cell membrane during the first stage of an action potential, which is polarization, the neuron is at rest and has not yet received an electrical impulse. Here can be seen the cross-section of the cell membrane. This right here is the phospholipid bilayer. The blue circles are the hydrophilic lipid heads, while the red tails, which are at the core, are hydrophobic. This purple channel that can be seen is for potassium ions to flow through, also known as K plus ions, while the green channel is the sodium or Na plus channel. Meanwhile, this blue circular pump is the sodium potassium pump. As can be seen at rest, the exterior of the cell membrane is much more positive in comparison to the relatively negative interior of the cell membrane. This is because on the outside, there are a substantially higher number of sodium ions, which are highlighted in yellow, compared to the relatively few numbers of potassium ions in purple. The exact opposite is true for the inside, where there are many more potassium ions and only a few sodium ions left by. In the next stage, when the neuron actually receives the action potential, it becomes depolarized. In this stage, the exterior of the cell membrane is much more negative compared to the positive interior. This is due to the fact that when it receives this electrical impulse, the potassium channel and the sodium potassium pump remain closed, as was in the resting phase. However, the difference between this phase and the resting phase is that now the sodium channels are actually open. This allows for a rapid influx of sodium ions from the exterior of the cell into the inside, leaving only a few ions of both types on the outside, but a relatively large cluster number of both potassium ions and sodium ions on the inside, creating an extremely positive environment.
Here in the third step of action potential, the sodium channel is closed along with the sodium and potassium pump. Here the interior of the cell is negative compared to the outside of the cell, which is positive. Due to the fact that there are significant amounts of both potassium and sodium ions in the interior, the potassium here is trying to escape the interior of the cell. This happens through the use of the potassium channel using diffusion. The potassium ions want to leave the cell, resulting in a negative charge in the interior. But by the end of this process, there are more potassium ions on the outside of the cell and sodium ions on the inside of the cell, which prompts the next stage. Here in the last step of action potential hyperpolarization, also known as the refractory period, both sodium and potassium channels are closed, but the sodium and potassium pump is open and can be used through ATP, making this an active transport process. Here, the pump is sending out 3 sodium ions and bringing in 2 potassium ions. At the end of this process leads the neuron returning to its original state, whereby resulting in the outside of the cell, which is much more positive compared to the inside of the cell, which is much more negative. This is because there are many more potassium ions in the inside and more sodium ions on the outside.